Okay, it's about 9:30 in the morning. So welcome everyone to this webinar. This webinar actually is organized and sponsored by the IEEE Power Electronics Society, in short, PALS Malaysia chapter. So today we have the speaker from University of Technology Malaysia, Dr. Rasman Ayub. The title of the webinar is Introduction to Photovoltaic System and its Considerations. Okay, before we hand over to Dr. Rasman, let's see, let me introduce myself. My name is Jiwei, and from Electrical Power Engineering Department, UTM as well. Okay, so I'm trying here to relate to what the topic will be presented by Dr. Rasman later. Let's have a look at here. I believe most of the attendees today are from the SKE 4653 students. Anyone here? Just a quick check, because I'm going to ask question and please answer. Open your speaker. All right. I'm sure that most of the attendees here knows what is renewable energy, but my question here is, what are the renewable energies available in Malaysia particularly? Anyone, please? Anyone turn on the microphone and talk to me? No one here? How many participants we have here?
Hydro, maybe?
Yes, thank you. Hydro. Any more?
Solar.
Solar.
Okay.
What else?
As far as I know, that's what I know.
In Malaysia, what else hydro, apart from hydro and solar, what else renewable energies that we can find in Malaysia particularly? Any other students here? Why so quiet? The answer is displayed on the slide, right? Can you see my slide?
Yes.
So what's the answer?
Geothermal. Okay.
Geothermal. Any more?
Biofuel.
Biofuel. Yes, thank you. Finish. Okay. Can we find wind power in Malaysia? Anyone? No, Rosanna said. What is the reason?
Not enough wind, maybe.
What do you mean by not enough wind? We have wind.
Not enough
The
wind
wind
speed.
energy is not really strong.
Yes, the keyword here is the wind velocity here. So the wind velocity in Malaysia is rather quite soft and slow. Okay, so it's not enough to power up the wind turbine. So we do not have wind power in Malaysia. So thank you for the participations here. Now let's proceed to the next slide here. I would like to highlight to you guys that the capacity in 2020 for the energy mix in Malaysia, if you look at the numbers on the left-hand side here, on the top part, actually we have non-renewable contribution about 76%. And renewable is actually 24% from the total energy mix. Okay, and if you look into the breakdowns of the renewable energies, mostly from the blue color part on the right hand side, the bar chart, the pie chart. So 72% from the 24% that we said just now, about 3/4 is from hydro or marine energy. And solar contribute about 17%, and 11% are from the bioenergy. So we can see here, these three components contribute a lot in most of the renewable penetration in Malaysia, particularly. But the constraint here that we have is we cannot simply open up new hydro or hydroelectricity dam. Okay, but the second contributor here is the solar, or we call it as a photovoltaic. We can easily expand the contribution of this 17%. Right, how do we do that? Let's talk about it later. Dr. Asman will share about the content later. Before that, let's have a look at this map. This is the map on the renewable energy resources, the potential in Malaysia. Yeah, what are the potentials that we can expand RE in Malaysia? So if you look at that, the yellow color, the big one, the big circle, yellow color is from the solar PV, which includes the ground-mounted rooftop as well as the floating installation. So actually we have lots of potential on the solar. Why is that? Anyone knows why do we have a lot of potential of solar in Malaysia? Again, quickly, please. Anyone?
There is a lot of land, free land to install solar.
Land, is it because of land the main issues that why PV is highly potential for installation? Is it because of land? What is the main input for PV?
The solar radiation.
Yes, so we're talking about the sunlight availability in Malaysia. So look at that. Which part of peninsula is more potential for PV? North of peninsula. So anyone from North Peninsula, you see that the solar irradiance is actually much higher compared to the south of peninsula. Same goes to the Sarawak and Sabah. So the small notes here on the lower part of the left-hand side here says that we have a 269 gigawatt potential for the PV. Yeah? So that is a lot to be explored in the near future. Okay, so what is the target for Malaysia in 2025? And another 10 years later, 2035. If you look at the numbers on the right-hand side, the RE share that I said in my previous slide, currently we have 24%, but in 2025, we're expecting to get 31% of the RE share. And then 10 years after that, in 2035, we should be able to achieve 40%. And that's a big number, actually. So the main contributors are from where? So you can see that on the left-hand side pictures there, we can have large hydro, we can have a small hydro, we can have biogas, and not to forget the yellow box on the right-hand side, which is solar. So solar is also the main contributor in all the available RE in Malaysia. So today the topic is focusing on solar only. So RE, why do we want to increase the target of RE actually? Anyone knows? What's the benefits of having more RE?
Reduce the emissions of CO2 and greenhouse gases.
Exactly. So that is the slide explained here. In 2035, we should be able to expect the reduction of CO2 down to up to 60%, yeah? 60% of reduction in CO2. Why bother to reduce CO2 actually? Anyone? Do you like CO2? Nobody here?
No.
Nobody here, or you know, no is the answer.
No, this answer.
Okay, you don't like CO2. Why? Why? CO2 is not good for health or what? Nobody knows?
We just need the oxygen only.
You need oxygen. But then if the capacity of the CO2 increase, what happened?
The
Global
average temperature of the earth increases.
Pressure of the air increases.
Yeah,
Good
the
point.
average temperature of the earth.
Temperature. Why temperature increase? All right, because of the blockage of the atmosphere, and that leads to the global warming. We don't like that. Right. Thank you. Okay. So let's see who is here. So today's speaker is Dr. Rasman Ayub. A brief introduction on the speaker, and the title is actually the introduction of a PV system and its consideration. And Dr. Rasma actually got his tertiary education from UTM, yeah, from the first degree, master's to PhD. So all in 2013, 2015, and 2018 respectively. So currently he is the senior lecturer with UTM and also a member of the Power Electronics and Drive Research Group under FKE UTM. Anyone here doesn't know him? I'm sure you know, yeah. And we are also the executive committee, the ExCom of PELS Society chapter, Malaysia chapter. And so this event webinar is actually one of the Power Electronics Malaysia chapter event, yearly event. So welcome to the presentation. Before we hand over to Dr. Rasman, I would like to take a picture with all the participants. Do you mind to turn on your camera? So we can take a quick picture. Yes. Any more cameras open? Okay. Only a few. Rosanna is here. Dr. Rasman, can you snap?
Okay, can. Okay.
Thank you, everyone. Smile.
Okay, I will take the picture. 1, 2, and 3. Okay, wait. Next page. Okay.
Attendance.
Okay. 1, 2, 3. Okay, next page. Okay, 1, 2, 3. Okay. That's it. Only 3 pages.
All right, thank you, everyone. So I hope that you enjoy the talk because the talk actually focused on the real application, the real implementation of PV system in a rural area for orang asli, betul? Yep.
Betul.
Okay, so you guys please participate in the talk. You can ask questions, share your thoughts, comments, etc. If you don't like to talk, please type your question on the chat box so that Dr. Rasman can respond to the questions and comments later. All right. Thank you, everyone. Dr. Rasman, I hand it over to you. And
Okay.
Thank you.
Thank you, Dr. Tan. Okay. So I will start. Wait. Okay. Assalamualaikum and good morning. How's everyone? Okay. Can you hear me? Okay. So today we will talk about the introduction to photovoltaic system and its consideration. And also I will also include a case study on the installation of PV system in indigenous people area, which is Kampung Tewowoh, Mersing, okay, in Johor. Okay, so I will start with the content. So there are 4 parts for this presentation, which is the first one, I will show you the PV characteristic and its power electronic use. Okay. And then the second one, I will show you the design consideration in PV generation system. Okay. And third part, I will show you the commercially available PV converter. Okay, and last one, I will show you the PV installation for the indigenous people, which is in Tewowoh, Mersing, Johor. Okay, so this is the first part, which is the PV characteristic and its power electronic. Okay, so you can see here, you have a PV current, voltage, and power characteristic. So at the center here is actually you change the irradiance. So S is considered irradiant or insolation. So basically, the higher the power from the sun, the higher the irradiance. Okay. Okay. So you can see here when you increase the irradiance, the unit is watt per meter squared. Okay. The voltage doesn't change too much. Okay. That is what happened to the PV characteristic of voltage and current. But when you increase the irradiance, it's actually affecting the current. It will become higher. Okay. So we usually don't look at the voltage and current. We all usually look at the power. So you can see here, you can see the blue line. When you increase the irradiance, which is the sunlight, okay, the power increase. Okay, it's for 600 watt per meter square. You can see here the the maximum power is around 300. 35. Okay, power 35 watt. But when the irradiance is 100 watt per meter square, the irradiance, the power produced can produce up to 60 watt. Okay, so basically means that the higher the irradiance, the higher the power. And also you can see here, it is non-linear characteristic. So basically you have to operate at this maximum power point here to ensure that the maximum power is produced from the PV. Okay, so besides beside the irradiance, okay, temperature also affecting the PV. Okay, so you can see here, when the temperature increase, okay, the current actually slightly increase. Okay, so that is what happened when the temperature. This is the module temperature, not the ambient temperature. Okay, make sure you know the difference between the module temperature and the ambient temperature. For example, if the temperature outside is 20 degrees Celsius, it's actually much hotter for the PV. PV is around maybe 45 degrees Celsius. Okay, for the current is only slightly changed. Okay, when the temperature increase, the irradiance slightly increase. But for the voltage is large change. Okay, you can see here, when the temperature increase, the voltage decrease. Okay, that is what happened. So how about the power? So you can see here, when the temperature increase, actually the power, maximum power can be produced, decrease. Okay, you can see here the light blue one. Okay, that's why we have to maintain the temperature lower for the PV. As I mentioned in my class, most of you are from my class. Okay, the floating PV is much more efficient. Why? Because due to the water, the temperature is reduced, so the power produced can increase more. Okay. So any question on the PV characteristic? No question, eh? Okay, so I proceed with the next part. Okay, so I also like to include the partial shading. Okay, so you can see here, partial shading is basically when some of the PV is shaded by maybe for a tree or a building. So as a result, you can see the blue line is actually the IV characteristic curve. So you can see instead of a smooth one like before, okay, a smooth one step later, okay, ladder, it becomes multiple step ladder. Okay, you can see here, because of the multiple irradiance received by the PV. So as a result, the power, you can see here, the red one is the power produced, okay, becomes multiple peak. So you can see here, the sub-assembly 2, okay, the center one have the highest peak. Okay, this is global maximum power. Okay, and the rest of it, assembly 1 and assembly 2, the two peak is called the local maximum power point. Okay. Okay, I think I see a question. Wait, Sorry, I don't know how to open the. Okay, I don't know how to open the type, the chat. Can you ask me directly?
Sorry, Doctor. Dr. Tan or Prof. Tan, asked if anyone had a question, and I sent him a question. It's not for the current slides. Sorry.
Oh, okay, okay. So I proceed or what?
Yes, please.
Okay.
Sorry to interrupt. The question is for me, yeah? What are the planned measures to ensure the stability of the grid due to the increased injection of solar or PV system, right?
Correct.
From Muhammad Hashim Saleh. Right, thank you for the questions. So now in Malaysia, I'm talking about the case in Malaysia, yeah? The penetration of the PV, especially for the large scale system, or we call it LSS, or the small scale, the one that you put it on the rooftop, okay? Beginning from the rooftop, actually you're starting from the feeder of the networks in the grid, and then up to the large scale system, LSS, which goes to the power systems planning. Okay, for either small scale or large scale new, we call it new installation or new planning. So before they install or they do it in the implementation, the deployment, basically the power producer or the supplier in Peninsula will be the TNB. They will definitely look into the stability issues. Okay, the existing network, whether the burden, or we call it the additional supply, will we call it will jeopardize the neighborhood or the neighboring grid. Okay, after the studies they make and ensure that there's no burden and no bad impacts on the existing grid, then only they will approve it, either is on the local feeder or the big power system level. Okay, so this stability issue is actually, I would call it, is being settled before they even do the installation. So from the point after they do the installation, so that stability issue come again, it's due to the fact to the nature environment, or we call it the irradiance, because the main impact here is the irradiance. Okay, so sometimes we have a very good irradiance, and then suddenly the cloud passing by. So there is actually a drastic change between the good sun and the bad weather. Okay, this will actually pose a very bad impact to the existing grid. Okay, so this issue is another stability issues which can be countered by having storage components. Okay, that is a brave answer to your question. I hope I answered that.
Yes, thank you.
All right, thank you. Please enjoy the talk.
Okay, thank you, Dr. Tan, for the answer. Okay, so we continue. Okay, I hope you understand the partial shading. Its effect is basically multiple peak power. Okay, so connection to the load. So you have a PV array, but if you connect directly to the load, so basically you will receive only DC, because PV array are usually DC. But the problem, if you connect directly the load to the PV array, is the voltage and current cannot be controlled. So you can see before the voltage here, you can see this is when the resistance is low. Okay, when you increase the resistance, is basically become higher and higher. Okay, the current, the voltage become higher and higher, and suddenly after certain point the current become reduced. So that is what happen if you connect directly PV load to the PV array. So basically voltage and current change drastically. Okay, so the best way to do this is the good way. Okay, is basically we just use a power converter. So power converter, you can the load can receive either DC or AC, and the voltage and current output can be controlled specific to the load requirement. If your load requires 230 volt AC, basically the power converter will make sure the output is it. Okay. And also you can implement MPPT algorithm. MPPT stands for maximum power point tracking. So basically it will search, you can see here, it will search the maximum power from the PV. So basically it will ensure that your investment in the PV is actually optimized. Okay. So this is the maximum power point tracking. Okay. So you can see here MPPT. Okay. So MPPT ensure the maximum power obtained from the PV. So you can see here when the temperature change, it can manage to obtain maximum power also. Okay. So the PV voltage and current IPV and PV is measured and fed into the MPPT algorithm. So you can see here it measures the voltage and current from the PV and goes into the MPPT algorithm, and then inside version of DC-DC converter here before connected to the load. So that is the function of MPPT, maximum power point tracking. It's basically try to obtain the maximum power point, MPP. Or in the partial shading case, is try to obtain the maximum, global maximum power point, basically the highest peak. Okay. So if you want to know how many types of MPPT algorithm, you can see here, this is some of the MPPT algorithm. So there are a lot of MPPT algorithms. So you have the measurement base, basically it measure the voltage and current of the PV and try to obtain the optimum power. And you have the calculation base, and then you have intelligent method. So intelligent method is basically you use some sort of optimization method, and then you have a hybrid method. So basically combination of certain intelligent method or measure-based method. Okay, the popular one I think most of you are usually heard is perturb and observe. Okay, PNO. And for intelligence, usually we use a particle swarm optimization. Okay. So you can see here, I already showed you before. So basically it will collect the data from the PV and send the control signal to the DC-DC converter. Okay, so I have here a PSO MPPT algorithm. So this is the animation. So you can see here, basically it tries to, the PSO MPPT tries to find the optimum peak. So basically it will try randomly first. Okay, you can see it will move around, try to find the best solution or best operating point to get the maximum power. And after certain point, you can see here, okay, it will obtain the global maximum. So the advantage of PSO is basically we try to obtain the highest peak. If you use the PNO, for example, PNO cannot find the global peak. Usually it will start somewhere here or here, okay? But PSO, it can find the global peak. Okay, we also I also would like to show you the PV converter efficiency. So you can see here, this is the PV input power, and then this is the output to the system. So you have MPPT efficiency and converter efficiency. So basically MPPT efficiency, the ability of the algorithm to get the optimum power, and the converter efficiency is basically the efficiency of the power converter itself. Okay. So basically, overall efficiency of the PV system depends on the MPPT and converter use. Okay, MPPT efficiency is quite high. Okay, because it's already improved many times. Okay, it's usually higher up to 90% and can reach almost 99%. Okay, but make sure you know that in partial shading condition, MPPT efficiency can drop significantly depending on the algorithm, because some algorithm cannot find the global MPP, okay, maximum power point. So this is the reason why it is important to avoid partial shading condition or use a good MPPT algorithm if partial shading cannot be avoided. Okay. So another thing that you need to consider is converter efficiency, which is depend on the topology and how many conversion used. You have single conversion or you have multiple conversion. And you have, if you use multiple conversion, the efficiency is much lower. Okay. So we move on to the next part. Okay, before I move on to the second part, you have any question on the basic concept of PV? Any question? Okay, if not, I will continue with the part 2, which is the design consideration in PV generation system. Okay, so for this slide, okay, for this talk webinar, okay, I group it into 5 consideration. Okay, so your first consideration is the output requirement, which is the requirement by the load. Okay, next is the sizing. The sizing is basically how many PV, how many energy storage that you need to use. Okay, and then the third one, you have to consider the controller. Okay, the controller for the PV system. And then the fourth one, whether you want to make connection to the grid or not. And lastly, the monitoring feature. So all of this consideration you need to take into account before you proceed with the project. Okay, so the first one, okay, is actually the output requirement. So basically, what is the required by your load? So the common in Malaysia is actually, if you are using DC, usually we use 5 volt, 12 volt, or 24 volt. Okay, but if you're using AC, it's usually 214 volt AC, 50 hertz single phase. But if you use 3 phase here, you can find the system that produce the 415 volt 50 hertz. Okay, this is specific for Malaysia. And of course, the power rating also needs to be considered when you're choosing the system. Okay, so output power rating affect the rating for the power converter and the cost. So the higher the load, the higher the power converter needed. Okay, and the cost, of course, the higher the power, the higher the cost. And of course, and also power rating affects the PV and energy storage voltage and current. Means that the higher the rating, of course, you need more PV and more PV and more battery. Okay, so that is the first consideration, which is the output requirement. Okay, we move on to the second consideration that you need to do. Okay, which is the sizing. Okay, so the sizing is to determine the number of PV and energy storage needed based on the load profile and the ambient condition. So you need to have a load profile, how the load change during the day and night. Okay, the best way if you have the load profile for 1 year. Okay, so you can size the system properly. And also the ambient condition, of course, for the PV, you need to have irradiance and temperature. Okay, because both are affecting the output of PV tremendously. Okay, so sizing is commonly done based on the energy requirement, like I said before. Okay, if your load is quite big, you have a large system. Okay, and also the importance of sizing is to ensure that the system, okay, the design you put is reliable and cost effective. Okay, if it's under design, it will not become reliable. Okay, your system will usually become, if your standalone system, it will shut down. But if the system is over designed, it will become less cost effective, which is costly. Okay, so this is one of the example of the sizing. Okay, you can see here LPSP is loss of power supply probability. So basically only 1% loss of power supply. Okay, so 99% you have the supply, but 1% you don't have the supply. And then this is the slope of the price. So basically you can see here the intersection of this point is basically the optimum size for this system. So basically you need 51 battery and 21 PV. So this is just an example. Okay, so sizing is look something like this. Okay, so next is the energy storage type. Okay, so you have a lot of energy storage available. Okay, so you can see here, you can use battery. Okay, battery is quite popular. You have lead acid, lithium ion, and many more. Okay. Beside battery, you also can use ultra capacitor. Ultra capacitor doesn't store a large energy, but it can provide a large power density. Okay. So if you have sudden change in load, the ultra capacitor can supply it for you. Okay. Another popular technology for the energy storage is compressed air. So basically, you have a tank. Okay. You have a compressor. You pump when you want to store the energy, you just pump the air into the tank. And when you want to release back the energy, you just release the air in the tank. And the motor or the compressor becomes the generator. Okay. So another energy storage type you can use is fuel cell and plus electrolyzer. So basically, you have an electrolyzer. Okay, you use the current. Okay, use the energy. Use the electrolyzer to change the water to hydrogen and oxygen. And then this, when you want to use back the energy, the hydrogen you put into the fuel cell, and it will convert back to electricity. Okay. So another types of energy storage that you can use is flywheel. Okay, flywheel technology. So basically, it's just like a top. Okay, in Malaysia we call it gasing. Okay, so basically you spin some sort of spinning top. Okay, when you want to store the energy, you increase the speed of the spinning top. Okay, but when you want to release it back, you just take the energy, the kinetic energy from the spinning, and you convert back into the electricity. And last example, another example of the energy storage system is the thermal energy storage. So this one, you usually can use some sort of salt or sand. Okay, you heat it up. Okay, you heat it from electrical energy, you heat it up, and when you want to use it, you convert the heat energy back to the electrical energy. So this is some of the energy storage that you can use for the system. Okay. So another things that you need to consider is energy limiter. Okay, this is focus more towards the battery. Okay. So if you look at your phone, okay, if you look at your phone, you usually see the percentage of your battery. So basically, that is called a SOC, state of charge. Okay, if your battery is full, is 100% SOC. But if your battery is almost depleted, you can call it 0% SOC. The new terms that I want to show you is called DOD, okay, depth of discharge. So what is depth of discharge? Is basically the capacity that is discharged from a fully charged battery divided by the battery nominal capacity. So basically, DOD equals to 1 minus SOC. Basically, the inverse of the SOC. DOD is the inverse of SOC. Okay. So for example here, if you are using your battery almost 20% SOC, basically your DOD is 80%. Okay. So basically, the smaller the DOD, the higher the battery cycle. So you can see here, if you use 100% of your DOD, basically you can just only use 200 cycle. Okay, if you fully use your battery, can only withstand 200 cycle. But if you reduce the DOD, okay, if you reduce the DOD, is basically prolong your life cycle number. Okay, so basically, smaller DOD, you can use battery longer. Okay, so commercial PV converter commonly equipped with energy limiter. Okay, if you buy the commercial PV converter, they have energy limiter, but the problem is it is based on voltage, which difficult to determine the DOD. So you have to buy a energy limiter. This is an example of energy limiter. Instead of using voltage, it will measure the energy. Okay, so it will determine the SOC and stop the operation when the SOC is when the DOD is achieved. Okay. So commonly, the energy limiter require the energy limit setting, and it will reset each day. Okay. So basically, you set it. Okay. For example, for one day you want to use for 1 kilowatt hour. Okay. So basically, after 1 kWh, the energy limiter will switch off and it will be resetted again on certain time every day. Okay. So you have any question on the energy limiter and the DOD? Any question? Okay. No question? Okay. So I hope you understand what is SOC and DOD and energy limiter. So we move on to the next part, which is sizing method. Okay. So remember that I said sizing is quite important because you want to make sure that the system is cost effective. So to do this, you have three methods. Okay. So the method is either estimation, software, and algorithm. Okay. So this is just to ensure that your system is cost effective and reliable. So I will move on to the first method, which is estimation. So for estimation, is basically you just use a simple calculation. Okay, instead of a complex calculation, you just only use a simple calculation. So basically, your irradiance, you don't need for the irradiance data. So basically, you just assume that in Malaysia, you have 3 hours of effective irradiance. Okay, it's actually not very accurate. Some location have higher irradiance, some location has lower irradiance. But for this estimation, we just set it to 3 hours. Okay, the advantage of using estimation is that the system is easy to use. Okay, you can just use Excel and a quick and simple calculation. But the problem is it's not too accurate, and it's only suitable for small system. If you use this for a large system, it will not be accurate and you can lose a lot of money. Okay. So the second method is using software. So I think some of you already know what is the software used for the sizing. Usually we heard about Homer, okay, PV Planner and PVCs, and there are a lot more software that can be used to size the system. Okay. The advantage of the software is easy to use. Okay, you can see here you just put what types of sub energy sources that is available, and then it will automatically calculate the optimum size for the system. But the problem is it's not very flexible. Okay, if you remember, the Malaysian tarif is somewhere like a step. Okay, the higher the energy you use, the higher the charge. But some software cannot allow that. Okay, so that is the meaning of not flexible. Okay, if you have a new type of energy sources, you cannot place it here. And of course, the disadvantage of using the software, it is very expensive. So you can see here, I think this one is Homer. The cost per month is almost $125. Okay, this is just per month and for base system. Okay, so if you have large system, you have to buy the expert one, and you have to buy it very expensive. Okay, so the third method is algorithm. Okay, this is how you size the system using algorithm. So example of the algorithm you can use is PSO, which is particle swarm optimization. Okay, the new one is Cuckoo search algorithm and Lion optimization. So basically, you write a code, okay, in programming language like C or MATLAB or Mathematica. Okay, so write the code. Okay, you have to model the PV, model the P-cell generator or something. Okay, and then you have to have the energy information, the irradiance, the temperature, the load. Okay, and you have to do some coding. Okay. The advantage of this system, the algorithm it is highly flexible. So you can just add any types of system here. But it is very complicated because you have to do the coding and it takes time to develop the code. Okay. And of course, it requires methodological data like irradiance and temperature. For the software, okay, this software, okay, the data, okay, the irradiance and temperature data is provided. Okay. But for the algorithm, you have to find it yourself. That is the disadvantage of using algorithm. Okay, any question for the sizing method? Any question? Okay, so we continue with the third consideration, which is the controller. Okay, when you want to buy the controller for the PV system, they usually show two types, either PWM or MPPT. Okay, so pulse width modulation or PWM usually costs lower. Okay, and it has simpler design. But the problem, if you choose the PWM, it has lower efficiency. Okay, probably around 60%. Okay, depending on the manufacturer, but typically it's around 60% because it's not operate at MPP. Okay, that's why the efficiency is lower. Okay, and because of the low efficiency, it requires more PV for the same load profile. Even though you can buy this at a lower cost, but you need to have more PV. Okay, that is for PWM controller PV system. Okay, if you want a more better solution, you can choose the maximum power point tracking MPPT controller. So the MPPT controller, of course, has the higher efficiency, but the cost is a little bit higher and the design is much more complex. Okay, for the MPPT, it can be either partial shading enabled and unable to operate in partial shading. So you have to look carefully whether the MPPT can operate in partial shading or not. And for the partial shading, okay, if the MPPT has partial shading capability, the cost will be higher. Okay. Okay. Do you have any question?
Excuse me, doctor.
Yeah.
The pulse width modulation type,
Yes.
it doesn't have a converter, doesn't track the maximum power point at all.
Yeah.
Just charges the battery.
Yeah. It's just charging the battery. That's it.
Okay. Okay.
Yeah. That's why it cannot operate optimally. But MPPT is much more higher efficiency, around 90%. Okay. Any question?
Yeah, me.
Okay.
Hello.
Hello.
Okay, Dr. Azman, how we decide to use MPPT instead of PWM?
Oh, MPPT
Uh,
or PWM.
For example, if you want to implement the solar PV at house, can we use only PWM? And the second question, what algorithm is used in the MPPT usually in industrial?
Okay. Thank you for the question.
Okay.
Okay. Actually, depending on your, usually for the small system, you can use a lower cost. Okay. PWM system for the small system. But for a bit larger system, I say it is better for you to choose the MPPT system because you need a lot more PV panel. Okay. And the second question is, sorry, what is the second question?
Hello.
Yeah.
What is the what type of algorithm is usually implemented in the MPPT controller?
Okay. For the MPPT controller, if not mistaken, is usually perturb and observe algorithm. That is the common one, but it's actually depending on the company. Okay, but the common one is the PNO, perturb and observe algorithm. Okay, any question? Any more question before we proceed? Okay, thank you, Rosanna and Muhammad, right? Okay, so we continue with the next part. Okay, grid connection. So when it comes to PV system, you can choose either two system, either standalone or grid type. Okay. So basically standalone, you do not connect to the grid. Okay. And the PV system is fully depend on the PV and energy storage. So when you have a standalone system, of course you need energy storage because PV only produce power during the day. But that night you need to have energy storage. That is the limitation of standalone system. And standalone system actually cost higher because you need to buy the energy storage. That is the limitation. Okay. And also becomes unreliable if not properly sized. If you don't have enough PV or battery, it will become unreliable. Okay, unreliable. Okay, suitable for place with no utility. Okay, Standalone system is good for the place where the grid system is far away. Okay, and if you want to install the grid to that location, it will be not cost effective. Okay, so that is standalone system, and another system is the GridTie. Okay, basically you connected the PV system to the grid. So this system is much more reliable because you have the grid to support the system. Okay, some systems are lower in cost since no energy storage is needed. Because you don't have energy storage, you don't have to buy the energy storage, the cost will be lower. And of course, for the GridTie, you have two types, either unidirectional, okay, only buys energy from the grid, okay, one direction, or bidirectional, you buy and sell energy to the grid, okay. Usually it's called new energy metering or feed-in tariff, okay. So you can see here, this is example of the, you know, okay, this is example of GridTie system. You can see here, this is the PV, the controller, DCSC, and then you connect it to the utility, okay. But this is for grid system, and this is for standalone system. You can see here, there is no grid connection, and you are based on energy storage. Okay, you have to install energy storage to be used during the night. Okay, the last thing, okay, that you need to consider, another thing that you need to consider is number 5, which is the monitoring feature. Okay, so basically it just help you to monitor how much the power is generated or how much energy is stored. Okay, how much cost energy you use from the grid, something like this. Okay, so the advantage is to monitor the PV system easily, and you can detect the problem quickly, and you can look for the power saving habit. Okay, so that is the advantage of monitoring feature, but the disadvantage is it will cost higher. Okay, so that's it for the consideration. Okay, now we will look at the commercially available PV converter, okay, which is part 3. Okay, so basically what is available at the market. Okay, you can see here, if you are focusing on DC output, okay, you can just buy the charge controller. So you can see here, this is the PV, this is the charge controller, you have the battery and the DC load. Okay, your load is fully DC. Okay, so this is known as charge controller. So you can see here, PV, battery, and the load. Okay, so it is available in PWM, lower in cost, and MPPT. Okay, and it's require constant battery connection. If you lose the battery connection, basically the system will shut down. Okay, and if you want to connect the AC load, okay, this is the AC load. Okay, you need a inverter. Okay, so this is the system. Okay, you have a DC load here, and from here you have to buy an inverter, and you connect the AC load. Okay, and also you need to know that some inverter may not be compatible with the charger controller. You have to connect it directly to the battery. That is just additional information. Okay, so another, if you are focusing on the AC output, you can buy a GridTie solar inverter. Okay, so it also known as GridTie solar inverter. Usually this type of GridTie solar inverter is bidirectional operation with the grid. Okay, and because it is bidirectional, you need to contract. Okay, this require contract with the energy supplier. Okay, so you have to look at the new energy new energy monitoring. Okay, you can search it. This is for Malaysian. Okay, it use new energy metering. You have to do some contract with the supplier, energy supplier, because this is bidirectional system. And of course, for this system, you have to find, you need a synchronization. Okay, basically synchronization, the algorithm used is the phase lock loop. Okay, so to connect to the grid, you can see when you use AC, you have phase. Okay, 30 degree, 60 degree, 90 degree, and so on. So when you want to connect to the grid, you need to ensure that the phase is the same. So that's why you need to have a synchronization feature. Okay. For the system, you don't need the battery. Okay. As a result, you have a low initial cost. Okay, and it's also available in PWM and MPPT. Okay, also available in single and three phase. And ultimately, the disadvantage of the system is basically when the grid is turned off. Okay, when the grid is turned off, basically this system is also turned off. So basically, if the grid shut down, your PV cannot operate. Okay, that is the limitation of the GridTie solar inverter. Okay, another type of solar inverter is AC output also, standalone solar inverter. For the name, it can be either standalone or off-grid or hybrid solar inverter. Okay, the terms vary depending on the manufacturer. Okay, so it's also available in PWM and MPPT, also available in single and three phase. Okay, some of the component may require a battery to operate. Okay. It also, some of it may have synchronization capability, and the new types also, okay, you can use a switchover, okay, something like this. Okay, this is the standalone solar inverter. Okay, so basically no grid connection, but if you want to put the grid connection, is basically you have to put a switch over here. Okay, basically if suddenly the battery is depleted, you have to switch over to the grid so the AC system can continue operate. Okay, so this is the another types of PV system that you can use, which is hybrid solar inverter. Okay, so basically you can see here, the grid is connected to the converter itself. So for this case, it is connected to the AC load. Okay, okay. But for this system is connected to the converter, the inverter itself. Okay, so this system is known as hybrid solar inverter. It is grid connected, operate in unidirectional. So this one means that you cannot sell and buy the energy. Okay, it's only one direction. Okay, it's also available in single and three phase, PWM and MPPT. Okay, and may have you have to have a battery to operate. Okay, depending on the model. Okay, may have synchronization capability. Okay, either the phase shift loop algorithm or communication link, depending on the model also. And AC load use energy from the PV. Okay, this is the method. So basically the AC load will use energy from the PV first. If the PV cannot support the system, it will try to use the battery. But if the battery cannot support the system, it will take the energy from the grid. So that is the hybrid solar inverter. Okay, so any question before I proceed to the case study?
Hi, doctor. Can you hear me?
Yes.
Okay, I'm Shah. Would like to ask you just one question.
Okay.
Okay, so like the inverter is following the grid. If it's on, then the grid is bila grid ada dia akan on.
Okay.
But assuming the voltage from the grid sometimes at the house is lower than the expected daripada TMB. So
Okay.
does the inverter follow the grid punya voltage or dia akan stabilize according to the ST punya requirement voltage?
It will follow the grid. Okay. The voltage produced the GridTie solar inverter always follow the grid. The voltage, the frequency, the phase always follow it.
Oh, so basically if the grid is under voltage, the inverter also follow the under voltage lah.
Yes, correct.
All right, thank you.
Okay, welcome.
Doctor,
Yes.
I'm Kelechi. I have a question on storage type.
Storage
My
type.
yeah, like the storage features you mentioned earlier.
Okay.
Yeah, so does any of these storage types or feature depend on any condition of the PV system?
Sorry, can you repeat it? I cannot understand the question.
Does the storage type depend on any condition or factor about the PV system, like before you choose to use either of them? Does it depend?
Also usually it's depend. Okay.
Okay.
Okay. I think for flywheel, you need to have a very large system. Also thermal energy storage. Usually for the large system, small system is not applicable. Usually we use a battery. And ultra capacitor are usually for the sudden change system. okay, support the transient during the transient state. This one usually for the EV actually, but not the PV system, but for EV system.
Okay.
Yeah.
Okay, thank you.
Okay, welcome. Any more question before I proceed to the next part?
I have a question. Sorry. Okay, go ahead.
Yes.
Apa beza pure sine inverter dengan non pure sine inverter?
Oh, pure sine. Okay, I don't have the image lah. Maybe I can annotate here. Okay. Pure sine is basically pure sine like this. Okay. Unpure sine is basically something like this. I cannot draw this.
Oh, dia bukan box doktor?
It's using box, something like a square wave. But during this, the square wave may be larger, but at this side, square wave may be smaller, something like that. That is not a pure one.
Oh.
I cannot draw because it's very specific. So basically,
okay,
square. Yeah, square, something like this. So basically, the square one, you can change to the pure sine. You just put a filter. Automatically, it changed the square into something like this.
Oh, okay. Faham.
Okay. Thank you. Akmal,
Yes.
Yeah, okay. So, any more question?
Sorry, Doctor, one last. Fuel cell, energy storage tadi?
Fuel cell, okay. What you want to ask on that?
Okay, on the fuel cell, basically, is it fuel cell is hydrogen only, or fuel cell is another kind of type of battery?
Oh, sorry, I only know hydrogen. I'm not sure whether there is other one or not.
Okay, all right. Thank you.
I think there is. I heard some call it salt, something like that. They use salt, not the salt, natrium chloride,
Sodium.
but other types. Sodium chloride, not that. Other chemical. But
okay.
I'm not sure. Okay, for that one, you need to ask someone that have the knowledge on the fuel cell.
Okay. Thank you.
Okay, welcome. Any question?
I have a question on the hybrid inverter. Can you go to the slide, please?
Hybrid inverter. Okay. Hybrid. Which hybrid? Because the what you call manufacturer, they usually interchange the name.
No, the last one. Yeah, this one.
This one, okay. Hybrid solar inverter. Okay.
Is there any types of it that will supply your load if the grid is offline and you don't have battery? Can it supply your load directly from the PV if you have sufficient radiation, or it's impossible?
This one, I think some of the model can operate without the battery. So basically, because PV is uncertain, right? The power, for example, this is 100. Okay, the load is 300. So basically, it takes 200 from here, right? Okay, so some of the model can do that, but some cannot. Some needs to take energy from battery first, depending on the design, actually.
Okay. But another case, if we don't have a battery and the grid is offline,
okay,
my load is lower than the PV, is it possible?
Cannot. Because PV is not stable, right? The PV is not stable. That can be a problem because, for example, PV produce 100. Okay, I give example, PV produce 100, the AC load is 200. So where they want to get another 100? So it needs to have a backup, either grid or battery.
Okay, what if the AC load is 50 watts and the PV is producing more than that?
Yeah, that is also a problem, right? It cannot, the extra energy cannot go anywhere.
Okay,
if you have battery, you can send it to the battery. If you have grid, you cannot send actually. You need to have some sort of agreement, right, to send the energy to the grid. Yeah.
Okay, understand.
So that's why you need to have this. Okay, any more question? Okay, if no more question, I will continue with the last part, which is the PV installation for indigenous people. Okay. So for the Tewowoh project, okay, so it is basically teamwork from various agencies. Okay, it is sponsored by Bank Islam under Sadaqah House program. Okay, so this is from Bank Islam, and it is led by Professor Madia TS Dr. Dasro Jamani Jamian from UTM. Okay, and also some other institute that also involved in this activity, which is Institut Latihan Perindustrian, ILP Kepala Batas, ILP Mersing, Polytechnic Port Dickson, Polytechnic Muazzam Shah, and College Community Segamat. They help to install the system. Okay, so this is the installed system. So basically the PWM 1 kilowatt standalone solar inverter. So because this is a small system, we just choose a PWM because it is much more cost effective. Okay, and we choose the standalone solar. We choose standalone system because there is no grid in the indigenous area. Okay, the grid is very far from the location. And the output is we use a standard one, which is the 230 volt AC 50 hertz one phase output. Okay, because the load, all the load they have, okay, they use is all AC. That's why we have to consider this output. And we use 2 PV, okay, 160 watt parallel, okay, with the battery of 160 ampere hour. Okay, and for the load, for the system is only 2 lamp and 1 fan, and we install it in 19 houses, consists of 145 indigenous people. So you can see here, this is the system. Of course, you have a DC distribution board, AC distribution board, okay, and you have a energy limiter. Okay. So this is the image of the hybrid solar inverter. Okay. So you can see here, this is the energy limiter. This is the AC switch. Okay. For the real system, you need to have a miniature MCB. Okay. You need to have a circuit breaker for safety, and you can see here the yellow, the green one is the grounding. Okay, the earth. Okay, and the EC distribution system is the DC distribution system board is here. Okay, so this is another image. So you have this is the AC, this is a DC distribution board. Okay, so we have 3 phases during the installation. The first phase is basically installing DB board and wiring. So basically at this house there is still no wiring. So basically we will install the wiring and of course the DB distribution board. Okay. We also do the knowledge transfer on the system and maintenance. Okay, although it sounds simple, knowledge transfer, but it is quite important. Okay, so PV is actually can withstand for 25 years if you take care of it. But if you don't take care of it, it can last only 1 year, usually 1 to 2 years only. Okay, so basically knowledge transfer is important. Basically, you just ask them to clean up the PV for every 3 months and do not put anything on the PV. So as you know, PV is actually quite hot. Okay, if you maybe for the temperature is only 20 degree, but the PV is actually quite hot, around 45 degrees Celsius. Okay, but if the temperature is higher, of course, the PV temperature is much more higher than the ambient temperature. So because of that, if they don't know, they put maybe some clothes there because they want to quickly dry it up. Okay, that becomes a problem. That's why the knowledge transfer is important, because we don't want them to put anything at the top of the PV. Okay, because it will cause the partial shading, and partial shading cause hotspot, and the hotspot will damage the PV. Okay, so that is the knowledge transfer. Not looks not important, but it's actually very important. Okay, and also you have to install the protection, the energy limiter, the lamp and fan, and DC and AC wiring. Okay, so the phase 2 system. Okay, so basically for the phase 2, we install the PV system on the roof. Okay, so install the solar inverter, battery, and PV panel at the top. Okay, so after we install it, we test the PV connection, and then we complete the earthing. Okay, and the last phase, which is the phase 3, the PV system testing. So the operation basically we just test whether the system operate or not. That is the last phase. Okay, during the installation, we have encountered several challenges. So off-road condition that is uneven and slow vehicle speed. So basically this location you can see at the bottom here, there is no what I call tar road. Okay, so we cannot drive very fast. Okay, that's why it takes time to go there, around 1 hour. Okay, and it also far from the main road. It's around 30 kilometer, but it takes almost 1 hour. Okay, because of the slow speed. Okay, we cannot go there too fast. Okay, takes time to travel and difficult if some component is unavailable. Okay, during this project, okay, maybe some screw we forget to bring. So we cannot complete the project. We have to wait until the next cycle to bring the component and install it. Okay, so that is the challenge. Okay, vehicle capacity to bring equipment, tools, people, and food. Okay, inside there is no food shop. We have to bring our own food and cook it. So you can see here. Okay, so you have to consider this into the vehicle capacity because we have to bring the equipment and tools and the people. Okay, so it is quite limited. So you can see here we try to adjust all the equipment, okay, the component to ensure that it can be fit. Okay, so also you have to consider the wildlife there. At that time the problem is on elephant. Okay, we have to open the electrical fence, okay, to prevent the elephant from entering the location. Okay, and then another challenge, you have to consider the roof condition. Okay, some of the building using asbestos, okay, and asbestos is brittle, it's hard to install the PV. But if some of the house use zinc, it's much more easier. Okay, and then if there is a tree, okay, some of the location they have tree and we cannot install it on the roof, we have to have a external structure to prevent from the shadow from the tree. And of course, another challenge is lifting heavy equipment like battery. Okay, so like I said before, the battery is 160 ampere hour. This one almost 50 kilogram. Okay, very heavy. So to carry it is very difficult. So this is some of the challenge during the installation of the PV system in the indigenous. But the benefit to the community is that before this community use a small diesel generator, okay, and they use during the night usually only 4 hours, okay, 4 hours at night, and RM 10 ringgit for each house per day. So basically each house has to pay 300 ringgit per month for the lighting and fan. Okay, usually only lighting, okay, and they only use 4 hours and it costs almost 300 ringgit per month. And because they use diesel generator, it is noisy. Okay, so after the PV installation, okay, the diesel cost for 300 ringgit, they can cut it because they only use the irradiance, the energy from the sun, and there is no noise from the diesel generator. So that is the advantage, the benefit that come to the Tewowoh community.
Projek pemasangan
Okay, so this is one of the video. Can you hear it? Wait, oh, you can hear it, because I have to set it. Okay, so if you can hear it, it's automatically set. Okay, this is the video for the project. I will show you.
Projek pemasangan tenaga elektrik solar di Kampung Orang Asli Tewowoh merupakan projek terakhir Kampung Orang Asli di negeri Johor yang belum pernah mendapat apa-apa bantuan untuk tenaga elektrik. Ianya juga merupakan salah satu program di bawah CSR Bank Islam Malaysia Berhad melalui program Sadaqah House. Bagi pihak UTM, khususnya Sekolah Kejuruteraan Elektrik, ini merupakan projek CSR yang keempat di antara pihak Bank Islam Malaysia Berhad dan UTM Johor Bahru. Selepas projek Eko Balai Rawatan Solar PV di Kampung Orang Asli Puchur, projek teknologi PV solar berpusat di Kampung Orang Asli Wuh Intik dan projek tenaga elektrik solar perkampungan Rumah Rakit Tanjung Surat. Secara umum, projek ini terdiri dari 3 fasa. Dalam fasa pertama iaitu pemasangan TV box dan pendawaian, satu sesi pemindahan ilmu tentang langkah-langkah menjaga peralatan yang penting seperti sekiranya berlaku banjir dan fasa pendawaian elektrik bagi kesemua rumah telah dijalankan, termasuk pemasangan sistem perlindungan arus ulang-alik dan arus terus, penghad tenaga, kipas dan lampu yang dijalankan pada Disember 2021. Keunikan penggunaan penghad tenaga dalam sistem yang dibekalkan adalah untuk mengawal penggunaan tenaga elektrik seharian bagi setiap rumah. Ianya secara tidak langsung akan menggalakkan budaya penjimatan tenaga elektrik di kalangan penduduk.
Fasa seterusnya iaitu fasa kedua, pemasangan sistem tenaga elektrik solar yang lengkap termasuk pemasangan panel solar, inverter dan bateri solar telah dijalankan pada Januari 2022. Pengujian lengkap kepada keseluruhan sistem tenaga elektrik solar bagi setiap rumah juga dijalankan dalam fasa ini. Dengan tajaan sepenuhnya dari Sedekah Haus Bank Islam, sistem tenaga elektrik solar yang dibekalkan ini membolehkan penduduk menggunakan bekalan elektrik berterusan yang selamat bagi beban lampu, kipas dan pengecas telefon di kesemua 19 rumah. Semoga dengan adanya bekalan elektrik solar ini, kualiti hidup penduduk perkampungan akan terus dipertingkatkan. Dalam fasa ketiga iaitu fasa yang terakhir, pengujian lengkap terhadap inverter dijalankan bagi memastikan keseluruhan sistem tenaga elektrik solar di setiap rumah berfungsi sepenuhnya. Sebelum ini, penduduk kebiasaannya menggunakan penjana diesel berkapasiti kecil untuk kegunaan 4 jam dengan kos setiap satu rumah RM10 atau bersamaan RM300 sebulan. Atas inisiatif terhadap permasalahan ini, sistem tenaga elektrik solar untuk 19 rumah di kawasan ini dibangunkan.
Bang, nak minta abang terangkan berapa lama abang dah pakai dan apa kebaikan yang abang dapat daripada projek Bank Islam dan UTM ni?
Ni kita pakai dah dekat 2 bulan lah. Lagipun kebaikan dia sebelum ni macam pakai genset ni kan satu malam 2 botol kali sebulan berapa?
Satu malam 2 botol tu berapa ringgit bang?
10.
RM10 satu malam. So kalau sebulan lebih kurang RM300 lah.
Yalah.
So bila ada solar ni?
Ada solar ni dah kita kira dah jimat lah. Bila time budak-budak nak sekolah pagi-pagi kan tak payah start engine dah.
Dah tak payah start engine, terus on saja. Lepas dah boleh.
Mas bersiap nak sekolah.
Okey.
Kamilah, so terima kasih lah ribuan terima kasih pada UTM. Terima kasih banyak-banyak.
Sama-sama.
Yang penaja Bank Islam ni bang. Yang punya penaja kita Bank Islam. Okey. So jumpa lagi.
Terima kasih banyak.
Okay.
Okay, that's it from the video. Okay.
Projek pemasangan tenaga.
So don't worry, if you are from international student, it's basically extracted information, the same information as the slide. All the information from the video is basically from the slide. Okay.
Projek.
So that's it. Thank you. Okay. Now we are open to question and answer, and don't forget to submit your attendance here. Okay. If you have any question, you can send. If you have further question, you can email it here. Okay, email to me here. Okay, any question?
Doktor.
Yes.
Apa ni, kan solar ni dia ada grounding kan?
Betul, ada grounding.
Grounding ni kita pakai grounding rod tu kan? Rod apa?
Yeah,
Copper rod
grounding
kan?
rod. Yeah, copper rod.
Copper rod tu masa kita tanam tu, kita kena check dulu ke ataupun kita boleh tanam je kat mana?
Oh, we have the meter to check the grounding.
Okay.
During I forget the measurement. I think it's less than. Sorry, I forget already. But we measure it to ensure it is quite low because we don't want anyone to get shocked from the PV system.
Itu lah reason kenapa kita tak grounding dekat ni.
Betul. Sebab ada AC.
Kalau apa tu boleh kalau contohnya kita tak letak grounding, ada potential ke kita punya solar punya sistem tu rosak?
Yang tu tak berapa pasti sangat sebab ada juga yang tak letak sebab rumah atas air. Kalau rumah atas air kita tak boleh nak grounding sangat kan. Tapi macam okey lagi lah kalau sistem kecil. Tapi kalau sistem besar saya rasa kena ada.
Sebab apa tu saya ada dekat rumah saya ada pakai satu sistem tau. Apa tu standalone punya sistem.
Okay.
And apa tu saya tak buat grounding dekat situ. Saya cuma apa tu saya tak buat grounding langsung lah. Saya just pakai inverter je kan. Tapi inverter saya inverter pure sine tau. Tapi saya tak pasti kenapa dia selalu rosak.
Kemungkinan lah tu kot ada grounding problem ke? Tak berapa pasti.
Saya nak confirm dengan doktor, tak apa. Okay. Thank you doktor.
Itu agak detail lah. Saya pun tak berapa tahu sangat pasal grounding ni. Mungkin kena cari pensyarah yang lebih pakar lah untuk grounding system.
Faham doktor. Okay. Terima kasih doktor.
Okay, sama.
Dr. Razman, saya ada soalan lah.
Okay, ya.
Dua soalan. Yang pertamanya yang kampung Tewowoh tadi tu,
betul.
Dia tak pakai genset langsung dah ke?
Betul, dah tak pakai genset. Ada sikit lah untuk nak pump air ke tandas kalau tak salah saya.
Okay. Lepas tu yang kedua, bila tadi tanya pasal grounding.
Okay.
Grounding untuk DC dengan AC masa kat Tewowoh tu combine ke atau asing?
Yang tu saya tak berapa pastilah. Rasa untuk AC je kita buat grounding. Untuk DC kita tak buat. Sebab DC dia terlalu rendah. Berapa ya? 24 rasanya. 24 volt.
Okay. Right, faham. Okay, terima kasih.
Okay, sama. Okay, is there any more question?
Excuse me, doctor.
Yes.
Regarding the attendance, which is the affiliation and the IE member?
Affiliation, you just put your UTM student, right?
Yes.
You just put UTM.
Okay, for IE member?
You are not IEEE member, right? You just said no.
Okay, and then no need for membership.
Membership, yeah, you don't have it, right? If you are a member, yes, you have it.
So I leave blank.
Just leave it blank.
Okay, thank you.
Okay, any more question?
Assalamualaikum, Dr. Razman.
Waalaikumsalam.
Yes, just thank you for the wonderful session. Just please would like to ask regarding the sizing methods.
Okay, sizing, yes.
Yeah, because you already mentioned that there are two of methods can be used, either
three methods
software,
actually.
Sorry.
3 methods.
Yeah, the softwares and the conventional methods, I mean in terms of algorithms.
Yeah, using algorithm.
Yes. since we already have like several algorithms in the literature, most of them saying that the recent algorithms are performing better the old algorithms. How can we differentiate between these algorithms in terms of providing like a better result or accuracy?
Oh, for me, I think if you want a more accurate result, you have to use a much more newer method, right? The like an Lion is actually much more accurate. I think you are doing Lion, right? Abdul Gadir, right?
Yes, I'm doing
Yeah.
Antiloan, yeah.
Yeah.
Improving
The
some
method is much more accurate and much more faster, right? Based on my reading.
yeah, of running
Yeah.
time.
Yeah. If you use PSO, I think it's quite long and it's not very accurate. Yeah.
Yeah,
So
if
if you are
an
focusing
example, if I want to
on
implement like a real example of installing a PV system, an example,
yes,
to which one will be providing like the better number of components, the actual result?
oh, for that one you need to do some
Software like Homa.
which algorithm? Yeah, yeah. Which better? Which one is better? For me right now is I think as Lion, right? It's much more better right now.
Yeah, for now,
Lion optimization.
most of the
Yeah.
researchers say that Antilion is better,
Yeah.
performing
So
better
you
in
can use
terms of
that,
running
but
time
it's
and
but
premature
complicated, right?
convergence.
Yes.
It's performing better in terms of running time and providing better result and addressing the local query result.
Yeah,
Local
it's much more
optimum.
better. Yeah. But the algorithm is a bit complicated compared to PSO, right?
Yeah.
Yeah, that's a little bit of problem because you want to implement it. I think PSO
Yeah,
is
this
much
is
more
the
easier.
disadvantage in comparison between the software and algorithms.
Oh, if you use software, it's still accurate, right?
It's inaccurate, but I mean in terms
inaccurate.
of reducing the mistakes, because the coding, if you have one mistake, the code will not work properly.
Yeah, that you can see the error, right? If you
Yes.
use coding, yeah.
Yeah. Thank you so much.
Okay, thank you, Abdul Gadir.
Okay.
Okay, any more question?
I have a question if you allow me. Did
Okay,
you
yes.
revisit the locations that you have installed PV and are the systems still working with no problems? Or
Yeah,
what are the common problems?
usually we will what you call revisit it again. Okay, actually last week I think the team go back to the location and check back. I think one of it on one of the system is broken, so inverter need to be replaced if not mistaken. I don't join them because I have class at that time. So yeah, we will check from time to time to ensure that the system continue to work.
How did the inverter fail? Does it have like a 10 to 5 years insurance on it?
Yeah, usually they have 5 years warranty, I think. Or 3 years warranty, but usually can work on almost 5 years. Yeah. But we cannot detect it. Usually we just, if it's under warranty, we just send it back. But usually we cannot detect it because we don't have the capability to check what's wrong with the system. But usually the inverter is the problem.
I understand. I have another question, if we have the time.
Okay.
Did the community get rid of the diesel generators for good after you install the PV system?
Actually, no. They still kept it because the water pumping. They still use the pump because they don't have piping, so they need the diesel generator to pump the water. Okay. The electricity, yes, we can use the PV, but for the pumping, we still need the diesel generator. But it is less cheaper, much more cheaper because we just get rid some of the load.
Okay, understood. Thank you.
I think it's commute. The diesel generator for the water is commute. So maybe it can reduce the cost. Maybe the generator is much more farther from the house. It will be less noisy. Okay. Any more question?
Hello, Dr. Azman. I'm Faris.
Yes.
I have one question. Regard you
Faris.
said that you have 160 ampere hour battery. Is it for individual home or it will be in general for all all home?
All home get one battery.
One
Each home
battery, which is
yeah.
160 ampere hour. How
Correct,
long
correct.
it can be used without charging? Do you have any data for that?
Use without charging. What do you
I
mean by that?
mean that if let's say we have not good weather, so is it possible for them to use, let's say, more than 5 days or something?
Oh, I think it's called the days of anatomy, DOA. I think.
Yeah.
If not mistaken, the calculation consists of 2 days. If not mistaken. Sorry, during the design, I'm not involved too much on it. But
I
if
see.
not mistaken, it's around 2 days.
2 days, yeah.
Yeah, 2 days.
And during actual, is it possible we get 2 days? I mean, just want to have a design and actual result. Is it possible to get 2 days without any charging? Do you have any data for that? No.
Oh, that one I don't have the data. Sorry.
Okay, no problem, no problem. Okay, that's all for me.
Okay, thank you, Faris. Okay, any more question? I think this is the last one because it's already 11, 30 minutes extra. Okay, if no more question, I would like to end the session. Okay. That's it. Thank you for attending the webinar. I hope the information I give can provide help you with your design of PV later. Okay. Picture I think no need no more because we already take picture before, right? Okay.
Thank you, Doctor.
Okay.
All right,
Thank
thank
you.
you, Dr. Azman.
Okay.
Salam, Dr.
Thank you.
Azman.
Yes.
Do you mind to share the materials for presentation in our group class?
Oh, the slide.
Yes, true.
Sorry, no. This is out of the class actually.
All right. Thank you.
Okay, thank you. See you again next week in the class. Okay.